Okay, welcome to Coffee Compiler Club. We're here today to talk about compilers and language runtimes and typing systems and whether or not it rains at Burning Man and anything in between. And you're being videoed, and the video will show up on YouTube generally within a couple of hours. And I don't have any set agenda. And usually somebody starts off with some report of whatever they were working on the last week, but anyone can go, or I'll talk about Burning Man, which is not compilers.
Were you able to download and upload the videos I sent you?
I did, and I thought I got them all. Cool. Just the two. I think they're up now. I didn't tweet the last one.
I haven't had a chance to check, so I was just asking.
Yeah. And somebody was saying you did a good job, and I haven't looked at them long enough.
At least one of them showed up in my YouTube recommendation. So
there you go.
What videos were these?
The previous 2 weeks. Videos come from Coffee Club once a week. I put them up under whatever YouTube at compilers.
Yeah, and I saw the last 2 weeks had been added.
And I went to Burning Man, right? So I was out for 2 weeks. Yeah. And so Cameron hosted.
Who else went to Burning Man? Anyone else?
No one quite crazy enough yet.
I think John Pampook went. You know John, right?
But he's not a regular on here. No, I don't have.
He's not a regular. He's never been to this one.
I mean, 70,000 people go to Burning Man every year, so a lot of people go.
But it's a small number out of 8 billion.
Although I don't know what percentage of the Silicon Valley tech companies go to Burning Man. It's a significant chunk.
I had this theory that if 70,000 people stand in a 1-inch deep water puddle and a lightning strikes, they wipe out Silicon Valley.
Decimate
something.
Yes.
Hey,
actually, people don't really know what decimate means. It only means to wipe out a tenth of.
A tenth, exactly.
Yeah.
No, that's why I was chuckling.
When your Roman legionnaire wants to improve morale, the beatings will continue until morale improved.
Right.
Not exactly the whatever bestest plan. All right, we're going to switch back to compilers here. What were we talking about? Well, we can get Dibiendu on here. He's talking about simple and what to do with parsers and lexers. No.
Yeah, we have to convince him to join.
You guys keep running him in circles, though. He's never going to get past the table of contents. So Bill, one of the members of this little group is trying to build a book showing from kind of start to finish how to do a sea of nodes / single static assignment architecture compiler, which was Cliff's. Cliff did the sea of nodes paper back in the mid-90s at Rice.
Mid-90s, yeah.
That was your PhD, right?
Yeah. Well, it was the appendix in the PhD because my advisor wouldn't give me a PhD for making a faster compiler. I mean, C2 stormed the world, but faster compiler was not important. So fine.
And Bill,
so I got a bit of math.
I sent you a note a couple of years ago, Bill, because I had stumbled on. I was doing an algorithm, and I was looking for something similar, and I found skip list. I was like, "This is so cool! This is exactly what I was looking for. It's basically what I was trying to build." Okay. And then I was looking at who built it, and it was like Bill Pugh. I know him. So that was awesome to kind of connect the dots. I had no idea that you were behind skip list. So
yeah. So although most of my academic research has technically been in the field of programming languages, most of it was actually, at least most of the early stuff, was algorithms and data structures for problems that came up in programming languages, and that was sort of what I did at Cornell in my PhD thesis. And so, skip list just was one of the things that popped out of that.
Yeah.
And FindBugs came along later. Skip list was first. I can do a little bit of interesting history. Many of my research projects are things that I just fell into. Okay.
So I'd been fooling around with Java for a bit. I'd been doing some work on class file compression, which actually turned into one of the JSRs.
Right.
As part of that, I had developed a whole tool chain for picking apart class files and analyzing them and doing stuff with them. And I'd also become good friends with Joshua Block, who'd written his Effective Java book. And I'm trying to remember if by the time I started FindBugs, I'd actually stepped in for as one of the Type It brothers for the stuff he used to do at Java 1. And I said, oh, let me take some of the bug patterns in Josh's book and see if I can find them in large code bases. And I started finding the bugs that Josh was describing, like in the JDK. And every other large library I looked at, because I worked on class files or jar files rather than source code. So anybody who distributed their Java programs, I could look for bugs in it. And that's like, oh, you can find obvious bugs in production code. And that started me, going more deeply into that area.
I remember after we had bought Sun and all the security bugs were blowing up with the JDK, and I think it was the labs group, so around Guy Steele and stuff. They had developed this tool that it did some automatic analysis and whatnot, based on, so it's like, okay, so we fixed this bug. Do we have any more of these? And it would turn out that like for every bug that they fixed, they could find, I don't know, 100, 150 additional incidences of like the same bug. Like again, the number, it's been years, so the numbers are probably off, but the automatic analysis was amazing what they would turn over, so it looked like they fixed, closed a couple hundred issues, but actually the number of issues that they closed behind the scenes was, tens of thousands. Like it was ridiculous.
Well, although, sorry, so we can just go down this path for a little while. One of the things I did a couple, so Google had been looking at using static analysis tools to improve the quality of their Java code base. And they'd done an initial bake-off of FindBugs, which was the project I developed at the university, and some other commercial tools. And they found that FindBugs was giving them better results than pretty much all the other commercial stuff. So I wound up working for a couple of summers and a sabbatical year at Google. And so first off, a little back off for people who haven't played with FindBugs. So we were looking for things that were like obvious. When it was pointed out to you, it was an obvious coding mistake, as opposed to more subtle things like security bugs. So an example of a obvious bug is strings in Java are immutable. And so if you see a statement like s.replace / with / and the return value being ignored, that's a mistake. Either you meant to say s equals s.replace, or the statement should be removed. There's no purpose. The statement by itself does nothing. And so we came up with a lot of those things. And when I ran it across the Google code base, I could find lots of errors. But and often I'd find bugs that had been there for months or years. Almost invariably, when I found a bug which had been there for many months or years, the bug didn't matter, right? Basically, the reason for that is that as code flows off developers' fingertips, it contains errors. And there are many different processes that remove errors from code. And most of the processes for removing errors from code focus on errors that actually cause things to go wrong. But then you'd find that when people write Java code, like, oh, well, I have to write an equals and hash code method, even though I don't know if it will ever be used, or this is some code that an intern wrote for some project that never got deployed, or something like that. So the code that contained mistakes that was never being executed, those bugs didn't get removed because nobody cared about them. The ones that were actually causing things to fail in unit tests, system tests, first deployment, those got removed. And so looking at bugs which had been in code for a year was very unproductive. And for example, that statement I said of s.replace / with /. Well, if that code's been in there for 2 years, you could fix it.
But it's going to break something.
But it might, maybe it was wrong to try to do it in the first place. Maybe it wasn't, but other people have coded to it, right? And so one
I
of the
think a lot
things,
of your DNA falls in that category.
yeah.
Mhm.
And
But
so
there
basically,
must be a bunch of things like, I know there's some Excel bug that's been in the code base for 40 years and no one's ever been able to find it. And, I wouldn't be surprised if some sort of static tool like this, finds occasional things which are just so weird, so off in a corner that, the bug has been there for years. It's so intermittent, so hard to get to that you never find it. But when you do, if you can get rid of it, it's like almost magic.
well, and this is an issue with the JDK libraries. And I've talked with Josh about this a fair bit. It is sometimes we find, okay, there's this weird, quirky behavior of one of the libraries, and it's not spec to behave that way. And it would be better and maybe more efficient if we did it a different way. But if we change it, there might be some bank software that depended upon the old behavior, so we can't change it. And so this, becomes a big
Somebody's law here about all things. Enough users make all properties visible.
Yeah, the undocumented behavior with enough users becomes, kind of part of the
Hiram's law.
implicit.
Hiram's
Hiram's
law.
law.
That sounds right.
And so the upshot of my sabbatical year at Google was that they sort of decided that the best thing to do with static analysis was to apply it as soon as possible after it came off developers' fingertips.
Mhm.
Because some of the bugs that I could find could also be found in unit tests, but it would take a lot longer in a unit test because, with FindBugs, a lot of the bugs, the code looked right. There was something subtle. They were like Java puzzlers. Why is this code behaving the way it was supposed to behave? And so it might have been found with a unit test if it wasn't found with static analysis, but it might take the programmer hours of trying to figure out why this doesn't work. And so they Google implemented a static analysis tool called ErrorProne, which is now used by Google, and it's actually run as part of the JDK. It's part of the Java C compiler, because you can plug in additional hooks for things that run there. And what they would typically do is they would port over some of the bug patterns we found from FindBugs, other bug patterns. They would find all occurrences of this bug pattern throughout the Google code base, decide, is this a bug which we no longer want to allow? If so, they would submit a change to basically patch all of the code that occurred that error. And Google has this amazing system called, is it Rosie, that allowed them to take a change list to fix a bunch of things in scattered projects, and would all get, rather than being one change list, it'd be parceled out to a whole bunch of different change lists for different projects. And once the code was fixed, they'd flip a switch and code with that error would never compile again at Google. So the thing of like calling string.replace and ignoring the return value would never compile at Google I'm not sure if that was one of the ones they put on their forbidden list, but they could do stuff like that. And, and they're very happy with that. But yeah, it was interesting. They found that finding all errors in a chunk of code and deciding, is this a real, and particularly, it's often the person who wrote the code, they've left the company, or was written 2 years ago. Who knows what else is dependent upon this? Saying like, yes, this is obviously not what the programmer intended. Is changing it appropriate? Will it improve things or make things worse? It's a huge amount of work. And so trying to do that for all the stupid mistakes, unless you know that they're causing problems, is probably not worthwhile. Now, these are different than security errors, right? Security errors you have to worry about, because if somebody finds an exploit, it could be really bad, right? And unfortunately, a lot of the security errors require a lot of interprocedural analysis, and they're really hard to find with static analysis.
So is it possible to do this type of thing for languages like Verilog? Because I can tell you that little latent errors in a Verilog code are more than extremely annoying. They cost millions of dollars.
FPDiv or whatever it was.
Are you saying this from experience by any chance, Darrick?
Oh.
No, what are you talking about?
there was no magic to FindBugs. I actually had trouble publishing an academic paper on it because I didn't use any sophisticated techniques to find the bugs. What I did is I either took like reports of bad programming patterns, or also as a professor, I had students doing programming projects. And when students came in with weird programming errors, I'd say like, oh, you're doing this error in your code. I could write something that looks for that. Let me write something and run across a huge code base. And if it turned out that, and I sometimes didn't say like, oh, well, in this case, it's okay. So I have to refine the bug pattern. And I do a little bit of that. And sometimes it wouldn't turn out to be something I could do, but sometimes like, yeah, this is really productive. And the nice thing is because I use simple techniques, the bugs were easy to explain to programmers. I didn't need to do, if you do a detailed interprocedural static analysis to find an error, explaining that error to a programmer is hard.
That's what I recall about FindBugs. The actual reported bugs were all sort of obvious as they stood.
Right. So I think and I've been seeing more of this in various other programming languages as I go forward. So for example, right now, most of my programming is in Swift, which I love. And a lot of the bug patterns from FindBugs are checked by the compiler.
Oh, right. Okay. Yeah.
Actually, I had a question about this, like just conceptually. I mean, this is subjective, but how do you decide where to draw the line between what to put in a compiler and what to put in the static analysis tool? Because I guess if you have bugs that have like no false positives, then that sounds like a good candidate for putting it in a compiler. But just generally, like, what are the criteria for putting it in one or the other?
One of the key things is with a static analysis tool, you typically have some sort of way to triage the bugs. What are the most serious ones? You often have tools that will tell you what are the new error patterns you're seeing that were not in the previous version of the code, right? You can easily ignore all the occurrences of this that have been in the code for like 2 years. I just want to look at what are the possible bug patterns that have been introduced since the last release, which has gone through all of our Q&A. Typically, if it's in the compiler, it's, if you really say it like, no, this won't compile, or your compiler starts generating a lot of warnings that people ignore, that's not good. So if you really want to make it part of the compiler, it really needs to be something where the ambient level of this bug pattern in your code base has got to be really low. Because like I said, a bug which is 2 years old probably doesn't matter. And if the tool is spitting out all these warnings about errors that don't matter, it should be in a static analysis tool where you can say, only show me the recently introduced patterns.
You're going to start.
But I think it's... Yeah, at Twitter, we used FindBugs with a bunch of rules that basically came down to things like, you cannot increase the number of java.util.random or java.url. And it would just be like, we're not going to get rid of all the existing java.util.randoms because who knows what exists in code base. But if you add another one, it's like, no, go use math cryptographic random. Don't use Java.
I think it's overall the argument in favor of putting more of these in the compiler, so you catch them straight away, and not later 2 years like after the problem was introduced. And I guess that's what Google was effectively doing, was adding this as a plugin to Java-C. They were basically shifting it towards the compiler checking this and not letting the code that contains such a pattern compile at all.
Right, but they sort of knew that if they came up with a bug pattern and then they found that like, oh, well, we have, Google's code base is Java code base is many millions of lines. And they say, oh, this bug pattern, there are 5,000 or 10,000 occurrences of this in the current library. And in order, the only way typically you can suppress these for the compiler is to put an annotation in the code to say suppress this annotation. And one of the things you find when you work in a large environment is touching the code at all making any change, even to a comment in code that hasn't been changed in 3 years, is a big challenge, right? Just getting permission to make that change. So the error-prone team, they only typically looked at the only ones that they really put into the system. And this was initially, things may have evolved over the past 8 or 10 years. I haven't really kept up with the error-prone teams, were ones where they were willing to like, okay, yes, the number of initial warnings is relatively small. We are willing to submit patches to change all of those. And then we can forbid it. But if, like I said, if you've got a large ambient number of that bug pattern, maybe the compiler isn't.
Yeah, I think there is a difference between existing language with a existing code base, and then it becomes a question of basically backward compatibility. Like if in a new version of your compiler, you suddenly reject some of the code patterns that were previously valid, well, you break backward compatibility and you create this headache for the developers.
You make a new language.
For a new language, yeah, to me, it sounds like an argument in favor of making more checks statically during compilation and just not let this kind of code exist at all.
Yes, although the other thing here, and one of the challenges for FindBugs and why I was reluctant to let go of control of it for a while, is that taste matters, right? The taste of which bugs are you actually going to complain about matters. There were a number of static tools out there that complained about, oh yeah, maybe that's not a great pattern, but trying to figure out what are the things that, yes, almost any educated developers say this code is bad. If it was pointed out at the time of code review, it would never go through.
So you were curating the signal to noise ratio,
right?
Yeah.
The one thing that I really want to know is how effective was interprocedural analysis, because that sounds pretty difficult to do, and I don't know how much results that would yield.
Well, so it depends. So FindBugs did very little in the way of interprocedural analysis. Basically, the only thing it did some non-null analysis of, like, does this method always return a non-null value? Does it always dereference this value, and so forth? I mean, for security stuff, you have to do a whole lot of stuff about taint analysis, which requires interprocedural analysis. How do I know that this value, which you're embedding in an HTML output, is actually sanitized? There's no way to do that without some level of interprocedural analysis and so forth. I deliberately, for many reasons, including the base that it was a Cruffield code base, which is working on the class files. And initially it was just like a single pass through the class files. I didn't do very much of interprocedural analysis, but for some types of bugs, you do need it. And they're harder to find and harder to explain. And there were big companies around trying to do, Coverity and Synopsys and so forth, built around trying to do sophisticated interprocedural analysis to find security bugs.
So Bill, now that we have, looks like kind of full quorum, why don't you give yourself another introduction so everyone knows who you are, since you're new, and then Thalia, am I pronouncing that correctly?
There's another new person.
I want to make sure that
Adrian's, I think, new, or I haven't seen you very often here. You got a bunch of folks. It's all good.
Sure.
So yeah.
All right. So quick introduction. So Bill Pugh, I started as a professor of computer science at University of Maryland back in 1988. Had a number of different papers in different areas that caught people's attention. I did skip lists, which is a randomized alternative to balanced trees. I worked on the Omega test and the Omega project, which was a tool for working with affine constraints over integer variables. It could analyze all sorts of things involving loops and array indices in scientific programs, transforming them for scientific computing. And one of the things that was interesting there was that for a long while, people had done algorithms that are guaranteed to be fast, but are conservative in whether or not there's a loop dependence that would prevent you from like running a loop in parallel or something like that. And what I actually implemented was an algorithm that was guaranteed to be correct, but would, well, with some side corners, was guaranteed to be correct, but potentially it could run very long. But in all the algorithms that the other algorithm, in all the cases where the other algorithms were guaranteed to be correct, my algorithm was guaranteed to be fast. And just in general, because the design of it, it actually handled complex cases, and people could do all sorts of crazy things with the tool in terms of, you know, show me the cache locations that are being touched by this portion of the loop and do transformations. I did that. Started working with Java. I found out that the original Java memory model that described how compiler optimizations could be done was completely broken. It was amusing to find something that Guy Steele had worked on that was broken. And that turned into a very long project trying to figure out, well, there were two things that had to be done for Java and threading. One is to figure out what are the semantics that define whether or not a program is correctly synchronized. And that has to do with how do atomics work and so forth. And then more complicated was figuring out if a program is incorrectly synchronized, if it has a legitimate data race, what behaviors are possible. Most every programming language says if your program has one synchronization error, the entire behavior of the program is undefined. And we didn't want to have that for Java. Turned out
damage is bounded.
Right. Turned out that that was very tricky, and we actually published some papers on it. And then turned out we missed some corner cases. I mean, I spent like 4 years trying to figure out an approach for that would work. And the thing we came up with didn't quite capture everything. And I think a few other people have carried on with that. Moved on to working with FindBugs, did some stuff having to do with helping students with programming projects. So this was an interesting thing. So as a professor, we have lots of students turning in programming projects. Typically the way this was done at Maryland and elsewhere is students would submit their programming projects to a Dropbox where nobody would look at it until after the project was due. And then you'd give a tarball of the final project from each student to a TA who would write up test cases and try to run that. And sometimes, you know, and get the results back to the students maybe a week after the project was due, if you were lucky. Instead, we had developed something where students could submit their project at any time. We'd run the public tests, which all students were given. And these should be the same as students were getting, but we did have a few cases where students would write something that would only work on their Windows laptop, but not on a Linux server, and would find that. But then the other thing is if they passed all the public tests, they could say, okay, I want to do a release test. And then there might be like 12 release tests. And would say like, okay, your code passed 7 release tests, but failed 5. And the names of the first 2 release tests you failed are, and then you give them the name of the tests. And the students could think, oh, well, I think I know what I might have done wrong. Change their code, resubmit. They can resubmit as often as they like, but they only get to perform 2 or 3 release tests a day. And so this would encourage students, when you find out that you failed a test, you don't want to say, oh, I think I know what the code is, what the error is, I'll fix it. The encouragement is try to replicate a test that fails, then fix your code, right? So that you have greater confidence that you will get past that error. It also encourages students to start submitting the project earlier, something everybody needs, so that they'd have more opportunities to do release tests. If you wait till the last day to really start working on the project, you only get 2 or 3 release tests.
How would you know what made it failed?
What made a test fail? They were all written.
Well, hopefully the tests have decent names.
Well, okay, so this was all JUnit, right? And they would have, so for example, there might be a project to identify poker hands, right? And you would have test cases like 1 pair, 2 pair, full house, straight.
Oh,
right?
I
And
see.
those would be the names of the tests, and wouldn't give the actual data, but you said like, okay, I'm failing test full house. Okay, well, let me try actually creating my own full house case. And instructors could decide if they wanted to use the full name, if they wanted to have a very descriptive name, or they wanted to have obscure names. People did different things. So did that. I found that my interests in the work I wanted to do tended to be very practical, solving real problems, and that always wasn't compatible with academic publication. And also they appointed a jackass for dean of our college. So I retired from the university back in 2012.
Is that a technical term? Jackass part?
Actually, I think the more narcissistic personality disorder was probably the more technical term. And actually, after I retired, that was the first time I was able to go to Burning Man. I went to Burning Man with Cliff, because Burning Man always conflicts with the start of the semester.
I'm the cause of all kind of trouble.
Yeah, I mean, I'd been doing all sorts of stuff in the maker space and so forth beforehand. Had a couple of years where I flipped around doing a couple things. We had one of our alumni who I worked with when he was a student was coming back to give keynote speech at our big hackathon. And a week before he was to arrive, it was announced that Facebook was buying his company Oculus for $2 billion. And while he was visiting, he said, "You guys could use a new building."
Was that Palmer?
No, that was Brendan Erie and also Michael Antonoff. We're both Maryland alumni. So I got involved. I pitched Brendan, I helped develop the pitch deck to take to Brendan on the building. I wound up getting involved with fundraising for the building and reaching out to alumni, and a bunch of other, and we've got a beautiful, highly functional, wonderful for students building. I'm very proud of it at Maryland.
That'll teach you to teach your students practical things instead of academic.
Let's see, fall. So, okay, so you're getting the full dump. Fall of 2019, youngest goes off to college. It's time for my wife and I to start traveling the world. We go to Southeast Asia for 6 weeks. We go to Antarctica with our kids. Beginning in 2020, my wife and I managed to squeeze in a trip to India before the pandemic shuts everything down. And then no more world travel. And then through a rather complicated work, I wound up working for Apple. And I worked for Apple for 3 years. I wound up working for Apple on the exposure notification system that Google and Apple developed to allow you to find out if you've been near somebody who later tested positive for COVID. And
did you work with Bob Lee on that at all?
Yes. So I'd started doing some work just talking about this before Google and Apple even came out with their stuff on it. And I'd been publishing stuff to Twitter and been writing up, white papers about all the complications and Google system. And Bob Lee saw that. And he turned out he was working with a group that was trying to build an app for that framework for the World Health Organization. And I was working with them for about a month or two. And as part of that, I was having like weekly meetings with the Apple team, and I drilled down on all sorts of questions about it. And after the fact, I heard that they were asking, who is this guy and how come he seems to know our system better than we do? And then when the turns out we weren't talking to the right people at the World Health Organization. So that got bogged down. And I sort of hinted to the Apple team, and they suggested me, would you like to come work for us? And I said, yes. And so I was working for them mostly remotely. And that was a lot of fun. And I could go on about that experience. Bob Lee, most of you probably heard, he was this person who was killed in San Francisco. I guess it was last spring. There was initially some thought that was just random San Francisco crime, but it turned out it was somebody new. It was a complicated, ugly story. And actually, I don't know, Cliff, did you get to see did you go to the temple? Did you see the memorial put up for Bob?
I went to the temple. I spent an hour or two. I had my own thing to leave. I did not see a Bob Lee, but I would have liked to have. I didn't know it was there. I would have looked if I known it was there.
I can send you pictures. I think it didn't go up until like Thursday or something like that.
Okay.
Because
Yeah, I
when I
might
went
have
there,
gone earlier.
when I went earlier in the week, I had something to leave at the temple. It wasn't there, but when I went there before the rain started, it was there.
Hmm.
So
Yeah, we were there before the rain started. I guess I
um,
fought my way back across Playa when the first of the rains really started coming in. Had a ferocious headwind and whiteouts and the whole 9 yards just getting back from temple.
Yeah.
Took some hours.
But I played around some with Objective-C and Swift before working with Apple, and my initial thing was building out. Well, actually, my first thing by working with the World Health Organization, I was able to get the entitlement, so I could actually get the exposure notification system to run on a phone. And my first thing was just writing some code to really understand the framework, because the API documentation was lacking. And was actually one of the things was interesting. So I had read every line of the API documentation. I'd written my app to try to figure out, I was figuring out all sorts of things that weren't documented in the API documentation. As soon as I get officially, okay, I'm an Apple employee, I have access to all this, I says, okay, show me the internal documentation about how this works. And they said, well, there's the API documentation. No, I've seen that. That's inadequate. I want to send how it works. Well, there's the code. Like, yeah, it's not really easy to understand it from the code. Is there internal documentation? Like, nope, that's it. Well, or you can talk to the engineers who wrote it, right? And
if they're still there.
My experience with JavaScript and React and React Native was, as ugly, if not uglier.
Right. And, one of the things, and I wound up being incredibly valuable to the Apple team, partially because, I'm a sort of a system designer algorithm. I went through and I stared at the code and I figured out a lot of the algorithms in my head, and I wrote down notes. And then when it turns like, oh shit, we have a bug that we shipped in iOS version 13.5, I understood the algorithms well enough to tell developers how they could patch around it. But one of the things, my experience working at Apple, is that I think one of the biggest challenges in software systems is both adequate documentation of code and keeping it in sync with the code. And actually, JavaDoc was an amazing thing that sort of moved in some direction to not have documentation and code completely distinct, but it's still
agreed.
JavaDoc was good at describing APIs, explaining like algorithms and how the system actually worked. It was harder to do in JavaDoc because that's often something that touches many parts of the code. The other thing I found in some of the code, so one of the challenges in the Apple code for this was there was some code that ran in the basically in the OS kernel, some code that ran sort of as an app. And whenever they were passing values back and forth, they had to do things like there's a whole bunch of marshalling and so forth to make a call into the operating system. And there was like a whole bunch of boilerplate code that had to be written to like take this data structure and marshal it into something that could be transmitted from the app into the operating system, then demarshalled on the other side. And like at least one of the serious bugs, because the marshalling code or demarshalling code wasn't written correctly. They left out a field that needed to be initialized. So
that code wasn't generated from struct definitions?
No, which was, and like, I was always curious, why wasn't it something that they were able to generate?
Yeah, right. This is like the obvious answer.
Right. But, one of my big things thinking about if I was ever going to get into academic research or thinking about what would be interesting in programming is, first off, we can do things about making compilers produce more efficient code and so forth, but allowing programmers to describe their code in a way that's as succinct as possible so they don't have to do boilerplate code, so that other people who come into the project 2 years later can understand the code.
That's my language.
Right. That is, yes, there are some places where it is really important that your code be performant, but there is a huge amount of code where allowing people to write code in a elegant way where they can just do the intellectually interesting stuff and don't have to do the boring, tedious stuff where it's easy to just get casual and make a mistake, and where other people can come in and understand the code. There's a huge amount of code where that is the most important thing. And I'm
think
actually
about that a lot. I did a bunch of hardware stuff, and there's the layout versus schematic checker. I have described my problem twice. Once as a layout and once as a schematic, and there's a piece of software that says, did you implement the same thing in the two places?
Right.
If the answer is no, well, you either have a bug in your layout or you have a bug in your schematic, but they disagree with each other. I've sometimes wanted
both.
that.
Come on. I mean,
Here's
go
my
for the-
serialization code. Here's the struct that you could have potentially derived the serialization code from, but I wanted to do something funny. There is no checker that's like, okay, well, here's my schematic for what it should be, and here's the code that I think serializes and deserializes it. Do these match? Like, that seems like it'd be a really useful question to be able to ask code.
Yeah.
Well,
and-
you want to wrap up, or you got more things here?
No, that's the main thing, other than I would say that I have been really impressed with Swift. And in particular, one of the things that I really am impressed by, anytime you're working with a programming language, like, for example, Java, that's been around for, what's Java been around for now? 30 years?
25 or 30, yeah. It's getting on.
No, it's 30 years. I
31
remember.
years internally, and published 1.0 was 96, so we're at 27.
Right. You run into so many constraints with a language that has been out that long and has so much existing code. One of the things that I would encourage everybody, like this is the one thing I sort of did on YouTube, is I got a videotape of Guy Steele's Growing a Language talk. And if you haven't looked at that talk, you'd find it on YouTube. It's great. One of the things which has impressed me about Swift is that they keep on chunking out some significant changes. And some of the things they do with it, with like Swift UI and being able to write domain-specific languages in Swift, is really impressive, and what they've done with macros. And I haven't kept. I don't know anything about. I know a little bit about Rust. I haven't followed it. I haven't picked up any new programming languages other than Swift in the past 10 years. But a language that can continue to evolve and do things that make it easier for programmers to write things as we find new patterns that we have to write. That's really interesting. I mean, as far as I know, Swift has done an amazing job at it. And I don't know what people thought about other languages that have continued to evolve. Like Java. I sort of got up to Java 8 or 9, but then I sort of stopped caring, partially because of my being upset with Oracle about how they tried to shaft all the people who put heart and soul into making Java better. And then Oracle said, screw you all. But
it's kind of back to marching forward at a reasonable pace with adding sort of sensible things.
Right. Yeah. But so, yeah, I'll leave it there. But other people talk for a while. I've hogged the floor for a while.
Oh, it's fun. It's all good. Yeah. Okay, well, I want to pick on Thalia here. Are you ready for like a 10-30 second intro? Anything?
Yeah, sure. So I'm Thalia. I just recently graduated, so I'm applying to PhD schools and whatnot. And now that I'm not involved with school all the time, I actually have free time, so I'm building a compiler. And so I watched your Sea of Nodes talk a couple weeks ago to do some architectural decisions from. So that's how I found you here, anyways. So I interned with the GraalVM team in Switzerland in 2021. I was on the compiler team building a loop optimization, counted loops. That was pretty fun. Got me exposure with the Sea of Nodes representation. Apparently I'm one of 7 people who understands the Graal loop infrastructure, so I thought that was pretty cool. Yeah, before that I did an internship with Grammatech doing static analysis work, and yeah, so I just live and breathe compilers. So yeah, happy to be here.
Yay!
And
Sounds
Talia,
great.
is it Talia or Thalia? How do you pronounce your name?
Talia.
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 So there is a discussion going on the Discord for this group where they're building a book and a demo and everything of a Sea of Nodes architecture. So if you're interested in contributing, I'm sure Diviendo would love the help.
Yeah, look for the Sea of Nodes project idea thread.
Okay, great.
All right, Adrian, can you give me a 10, 20 second?
I think I introduced myself before, but
I was just thinking.
Yeah, I mean, basically, I'm a nerd. I like operating systems. I obsess about performance a lot. I like doing things from scratch, especially when they're not economically viable. And yeah, most of the time, my desire for working on software comes from the frustration I experience from accidental complexity. So, yeah, right.
Cool. And then Levo, you wanted to demo your language server for Bolin, is that right?
No, I'm doing some exploratory work with LSPs, but it's not for Bolin. I was just doing some research, and I figured that you guys might want to look at it.
Yeah.
I don't know. Do you guys want to see LSPs or no?
I'm willing.
Okay. So I'm not used to sharing my screen because this is a different distro. Okay,
I've enabled it.
Now.
There you go. Yeah. Oh, I can see myself. Let me.
Yeah, we have to see it too.
Do you guys see? I'm not sure if you can see my cursor.
Your screen.
I want to hear other people say something.
We see all your VS Code stuff.
Okay, so I'm gonna hit F5. So last week, I was saying that I kind of feel like writing a text editor, and Cameron said the wrong thing. He said it should only take a week or so. So obviously, I started thinking.
Only 3 days to write curl, right?
Yeah. So I was thinking. I know that GUI is supposed to be hard and all that, but I can't actually think of a logical reason why it should be hard.
I'm not supposed to be evil, but it turns out sometimes.
So you can see I have 3 windows up here, and you can see some highlighting. And
this is your editor?
So, yeah.
And how long did it take you?
Literally, I started after last week's coffee compiler, so exactly 1 week.
Nice. So
you can see that if I click stuff here, it actually brings me, and this shows the lines, and this is coming from an LSP. So these are Clang, and the bottom which is JavaScript. That's using quick lints.js, and I'm just going to do make dir or so this is in my temporary folder. So you can see. Hopefully you can see my terminal, but there's no files in there. So when I run this, you can see files are here. So I'm just going to do a cat. It should be out, or no, it's in. So this is the JSON string I'm starting with. Actually, I'm going to go to desktop and show you how I actually started this.
And that's the output from the language.
No. This is actually just the inputs. It's extremely simple. I will explain it, but so you can see how I have Clang D here. So what I did, I'm just going to cat it. You can see that it's not actually Clang D. So essentially, I did export. I changed the path so it will find this Clang D first, and it just does a T onto the it's a temp file, and then I use that to actually see the data, and this is the data I got. So I got my IDE to or the text editor to spit out this data to the language server, and I started getting the input. So I'm just going to make another terminal cd lsp. So if this was in, then I want to see the output. LSP So I keep on changing things, so I'm just like not used to the actual commands to write. I'm not sure why this is not auto completing. .txt. Oh yeah. Okay. Anyway. So anyway, the LSPs are actually just extremely simple. You start with content length, colon, and then you give it the size. You do 2 new lines. It's like cartridge return new line, cartridge return a new line, and then the size of the content. I think the size is after it's been escaped, but I'm not. I don't remember. So the beginning is I just basically repeated what VS Code sent out, except I changed the path and the name of a few things, but that part's not important. That's very easy. You do content length again, you say initialize, and then you can say what you want. So the first thing you do is did open, and then that
You're
will
using
get you.
content length only as a framing mechanism?
Pardon?
You're using content length just to frame the messages, so you know how long they are.
Yeah, so the language server protocol says you say the content length, new line, or cartridge return, new line, cartridge return, new line, and then the actual like JSON message. It's like I'm not sure what's required. Like I don't know if you actually have to say JSON RPC, but anyway, this entire message is this many bytes. So the initialization will get you a message. You can see the ID 0 that matches up to ID 0 here. This I think is just a Clang thing. There's no ID. It just says it says method. So if it's replying to something, I don't think it says method. I think it says it gives you the ID of what it's replying to. So over here you can see it's giving the server is giving the client another message, and this publish diagnostics that happens after you do did open. So did open is yeah, this is like the actual like file that escaped into a JSON message. So so the diagnostics is comes happens after this. So that's how I'm getting this information over here. So I have 2 LSPs that I'm using. The other one is a JSON LSP. I'm just going to cat that out really quickly, and then I'm going to move on. So this one's a lot less messages, but you can see it says severity. It says the source, the actual message, which is use of undeclared of variable. Yeah, so use of undeclared variable. So yeah, and like I said, it's only been a week. The LSP file is not even that big. I use I was writing my own SIMD parser, I mean JSON parser, but I'm like, I really do need all the information, and I didn't want to write like if I'm going to write it, I'm very likely to try to optimize it. But I'll just use SIMD JSON. Like it's not my favorite thing, but it's pretty decent. So yeah.
Nice.
I don't know what you guys what else you guys want to see, but
Yes, my 2 questions are: how are you rendering pixels to the screen, and why CPP?
why CPP, or what'd you say?
Why C++?
So
I
I'm
saw
just
it
really
is
used to C++. And I figure if I would make an editor, I will want it to go fast. So if you want to go fast, you use C++. So I use SDL. So basically everything is a frame buffer. I'm going to do render source. So let's go to the bottom of this. So essentially I created an atlas of, I wonder if I can show it. Maybe not. I'm not prepared. It would be commented out, and yeah, I don't think I can show it. unless it was this thing right here. No, it's render string. Okay, yeah, so I can't really show it, but essentially I have some code that it writes space, and then it doesn't write space. It writes all the ASCII characters above space, but below 7F. So it puts that into an atlas, and then basically every character is monospace. So I know what the width is, and the height is going to be the same. It's not the same as the width, but width and heights are the same for every character. It's monospace. I basically just have a loop going for every character and then just drawing it on screen. It doesn't support UTF-8 yet. It's just ASCII, but I don't have any UTF-8 in my source code. So yeah, it's only been a week, so no need for UTF-8 yet. So
I need emoji support.
You can get that in a few months if you ask really, really nicely. I think there's a render string function that I can show.
So
How
remember the
about
first time I
animated
saw a
GIFs?
bug report that you couldn't do certain things when you named your VM.
You can do certain things when you what?
I saw a bug when I was at Google that if you named your VM snowman emoji, certain things didn't work because some of the tools assumed that the first character of the name of a virtual machine was an alphabetic character.
I see. So anyways, render string, you would do something like some text, XY, and then display information holds the SDL stuff to like render the window, like textures, the heights of the ASCII characters and the renderer. So essentially, I look at the character. I have a special case for space. I just increase the width and I don't render anything. This is space is 21, I believe, or I don't remember.
Normalizing for all the control characters.
Space is 20.
Yeah.
So I guess I just want the 21st to be the 0. So yeah, okay, that's correct. So I basically figure out what the column and the row is. Then in the Alice, I know that the column is each thing is the width of the ASCII character, each thing is the height, and then I just render. It's basically a frame buffer. It's really, really simple. So yeah, do a text editor in a week. And ironically, you can't actually edit any text. I just want to get the LSPs and
you're rendering, but you're not editing.
Yeah.
Yeah, right. Okay, fine.
So yeah, and that's it for my
what
demo.
structure do you plan to support for editing? Which is tricky part.
Which what?
You actually
Which
gonna go,
structure?
hey, C. Arthur.
Just go with ed command, and then you're almost done.
Which structure do you plan for editing text?
BI or Emacs? You have to choose.
Oh, yeah, I was thinking you would just configure it, but I want to start with something that would be mostly keyboard based, but you can get away with like clicking, so people who are not used to it can like be somewhat productive. But then I plan to like go heavy into some of the more bindings like Vim and Emacs. So I haven't chosen a winner yet. But I'm probably just going to do some random.
I'm going to stop sharing here and go back to random discussion mode. That was nice looking though.
Yeah.
Yeah. Well, the other thing, so I think what he was asking about is like, what data structure are you using for the text? Because like I know like there's this Rust library that like uses ropes or something. It's a very efficient editing text. And so, I mean, I know you hate Rust, so you probably won't use it, but I'm just saying, you know, there have been like several actual editors that people have written that use this library. I forget what it's called, but.
And someone has to mention Tree Sitter at least once.
Oh, no, fine.
So the highlighting I just did myself because, you know, I written a parser and a lexer for my language, and then I written another syntax highlighter for my website. So I basically I did something similar to what I did for my website to highlight the text. It's essentially just looking for reserved keywords, and it knows the difference between variables and variables, reserved words, spaces, digits,
So
and
what would happen?
operators.
Levo, what would happen if you edit something in the middle of the file or the page? Do you have to re-highlight the all of the text, or just the?
So right now it just it does it dynamically. It just looks at what's visible in the page, and then it just starts highlighting from there. And one thing I noticed, like this is just prototype code. One thing I noticed is if you scroll, you know how in VS Code or in a lot of things, the parentheses are changes colors based on how much it's indented, or if you have a open parentheses a bunch of times, they're all different colors, so it's easier to match. So I implemented that, but as I scroll, that changes because things that open brackets go off screen, and then the syntax color changes.
Yeah,
so I got to figure something out.
Yeah, that's not psychedelic rainbow parentheses.
Yeah, you need different structure to count the whole file that you can slice in the middle of.
Yeah,
so basically there are two kind of structure. One is the rope, and there are a buffer of lines. If you will, there are multiple of techniques in order to keep.
I'd say Emacs has been around a while, predates things like ropes, but it's just a couple buffer chunks, very similar to ropes.
Yeah. That's you hold the lines in a buffer, all of the text, so it's easy editing.
It's also interesting to think about how are you going to implement the undo and redo operations.
Oh yeah,
because you may need to do some kind of a tree
I
to
figured
basically allow the users to walk back and forth.
You guys are going to get them off of doing Bolin and onto doing an editor now. We're not going to get a language out of it.
I'm surprised I don't see Alan like rubbing his hands together in an evil way.
So Levo,
no, like
Levo,
I want
could
to
you possibly add a Chat GPT integration with the editor?
Yeah, so I knew that I could get something reasonable in a week. I would say what I just did was very reasonable. I have no idea how long it would take to write a full editor, but I think I do want to write a little bit more to get GDB running, because I really dislike debugging with GDB now with VS Code, because the more complicated thing I have to do, like I really need every function to change what variables I'm watching, and I hate typing it out, and I hate having like 20 or 30 things in the watch window. So I think I might have to do at least some kind of debugger. So I might do that, and I don't have to edit text with debugger. So yeah, I might go that far, but I'm not sure about the actual text editor.
Yeah, you should be able to do a debugger in 3 days.
Yeah, but you know what? Yesterday, I did GDB dash interpreter equals mi2, and then I wrote I written some commands, and my editor actually does pull out the file name of when you do a breakpoint or segfault. So, and which I do not segfaults, aborts. So when I hit an insert, my editor knows what line it's on. Now, having that actually implemented, like jumping to the file and opening it, that's not implemented. But I do know it's going to be easy to do, and I have parsed it. So, I'm like halfway there, I think. It's not that complicated. Like, people say things are complicated, but, you just saw what I did in a week, so it's probably not that complicated. But I also don't have any dependencies. I'm using a frame buffer, so yeah, if you just simplify your stack, things can get done.
I mean, that was like kind of code I wrote back when I was a kid doing Nintendo-ish games way back in the day. You slapped up a buffer and you could just throw bits in it. Fucking showed up.
Yeah, and the thing is, the binary is not 100 megabytes. Yes. I don't even know what VS Code does anymore.
You crazy kids with your 16-bit processors, you have no idea how hard it really was.
Well, there's a big difference between writing like an editor that doesn't actually edit any text and writing an editor.
Well, he's got a text viewer.
It's
It's
been
got
a
a nice,
week.
fast color.
It's
Right,
been a
no,
week,
no, but that's
and
what
I
I'm
have
saying.
LSPs.
Is you're contradicting yourself. You're on the one hand, you're like, this is just something I threw together in a week. It doesn't do very much, blah blah blah. And then like you're on the other hand, I wrote this editor. It's the best editor in the world. Like you've never seen an editor that's so good.
Yeah, I don't think I'm
What do
doing
you
that.
think is harder, highlighting text or an undo?
Undo.
So
Really?
just to be clear though, I have worked with quite a few programmers that I think Levo's editor is perfect for, as it is right now, without the ability to change
edit?
code. Yes.
Yes. So Levo, undo is easy if you can only add characters or up and down backspace a few. But if you have interesting region selection, cut and paste and search and replace and all these kind of things, and then you want to undo an arbitrary amount, like I sit my Emacs and I can hit the undo button for days and it'll just roll all the way back.
Yeah, so Levo, I would
challenge.
suggest actually searching for articles on the topic, because I've actually read a few over the years that are really good, because it's all about data structures with undo.
Yeah.
That's why I think it's the easiest thing, because
it doesn't
know how to
have
write
to
my
be
data
hard.
structure.
It doesn't
I have a simple project. I have a simple project idea. Now only allowed to type code that is correct.
And we'll use the verifier from ChatGPT to confirm that it's correct. Is that what I'm hearing?
One of those inter-procedural analyzers. Shouldn't take more than 3 days.
I just want the memory management, the auto memory management thing out of Levo here.
Oh yeah, just insert free and or delete for every new. I mean, that shouldn't be hard.
I think we're into teasing Levo now. This is like no good. That's just it was a nice piece of work
very
there,
impressive,
Levo. I would love to see more.
Very impressive.
So Levo, I have a question. I mean, this could just be a programming project to, explore a topic and develop your skills and so forth, or it could be something that you think like, oh yes, I plan to put more time into this and want to turn this into something that me or other people could actually use as their main editor. What is your what is your goal in writing this? And is it somewhere in there, something else?
My goal was actually just to get it out of my system, because okay, I think I just have to explain a little thing first. Is I'm pretty far along in my language, and I've been working on it for like quite a while now, and so I knew like if the code is just something I read myself, it's always easy. The hard part is always interacting with something like the Linux kernel has an ABI. Learning the ABI was much harder than a lot of things in the compiler. So I knew that anything that I have to do with other people's code is always going to be the hardest part. And I knew I eventually wanted to do an LSP for my compiler. I had a prototype a couple years ago written in C#, because C# makes JSON parsing and generating very easy. So I knew a little bit about that, but I just wanted to refresh my memory. Because I was thinking I might want to do an LSP while I'm doing memory safety. So at this point right now, I'm doing memory safety just because it's getting in my way. Having no memory safety is getting in my way because my compiler complains knowing that things are incorrect. So I have to do the memory safety, and I figured that I might as well do the LSP as like a second thing, just because sometimes it's boring to do one thing and only one thing. But anyway, the reason why I did this editor is because it just kept on popping in my mind, and I knew it's not going to be difficult. So I just did it to get out of my system, and I knew that learning about the LSP is going to be useful sometime soon. So it was both getting it out of my system and refreshing my memory on how to implement an LSP.
Okay. I mean, one of the things, just general warning about anything, is if you actually produce an open source project that a bunch of either other people find useful, you might find yourself with having to care for that for a long period of time.
That's why I don't open source things by default. And I had bad experiences with open source in the past, and yeah.
So, I mean, coming up with a good project, like I want to learn how this system works. I want to flex my skills, develop new skills. That's great. Trying to come up with something that, it's one of the things which is insanely hard in the programming language, the compiler world, is coming up with something that will ever get enough critical mass so it gets widely used is hugely hard. There's so many efforts that come up and just never get that critical mass. And of course, if they do, then you have a whole nother set of problems.
Yeah, so one of the things I'm worried about memory safety is so in my compiler, when I originally joined here in February, I was doing 2 million lines per second, and currently it does 3 million lines per second for a debug build. And I also have it like fully multi-threaded, and literally no one cared. And I'm a little bit worried that when I implement memory safety, no one's going to care, and no one's going to use the language. So I'm a little bit. So that's part of my concern.
But you're right. But you're right to be worried. I mean, we've talked about it a little bit, but people, for sake of a better explanation, people don't buy features. Features are worth zero, right? Solutions are worth something, right? And the problem is until you have an entire set of things that makes a cohesive solution, or at least enough of them that you can hand wave around what you're missing so that people believe you're going to get there. Until you have that, it's very difficult to show any value and thus attract people to use and or invest and or buy and whatever it is. So it is a harsh step function you have to get to.
See, I thought someone would ask me how to implement it, but no one asked me how I implemented multi-threads in my compiler.
I would also add that performance is exciting and interesting for a complete project, and not at all interesting for one that's not complete, because you could assume that it could go off a cliff as soon as some important feature that has to be in there actually lands. So it's just a sort of vanity metric until the project is done.
Yeah, so I think one of the first things I'll want to implement is being able to serve HTTP requests. So I don't know if I want to eventually have my text viewer be part of my language. Maybe I can have it as like a default. Because if I end up wanting to do a lot of things that are not supported in the LSP, maybe I want to throw it into my editor, or maybe I want to make debugging much better, and then have that associated with my my compiler. But I really have no idea what I'm going to do with the text editor, and I have no idea what people are going to think about memory safety until they can actually write some HTTP requests or servers or whatever.
So I would say they're like HTTP is definitely a good start. I guess it depends. Do you also want to write your own TLS stack, or are you going to use something like OpenSSL? Because if you use OpenSSL, for example, or LibreSSL, or many of the variations, it becomes easier, ignoring the sort of distribution part of things. But if you want to write your own stack, I guess you can add 6 months of work to the to-do list. But
3 days.
I'm not sure if if your name is Cliff Click, maybe, but for the rest of us mere mortals.
Cameron, I would hate to see you as a gambler.
But my point was more I think an editor is actually a pretty good sort of test case of your language, the sort of stress test, catch bugs, because you can do things that, like implement certain algorithms, data structures, that sort of thing. But I suspect once you've done a few of those, you can do another 50 of them, and you're not going to catch any new bugs because they all sort of fall on kind of I guess you call it the same style as how they're written, I would say. I guess the same set of features.
Same set of domain problems too, yeah.
Right. But so as an example, one thing I did in my language, I wrote a piece of software that controls our HVAC system. And that involves some HTTP because it has to talk to some sensors that I have running. It involves some I think I had to do like JSON parsing for configuration files, a bunch of other things. And that helped catch quite a few bugs, in particular in how my language compiles pattern matching. Because you end up with these sort of edge cases where the combination of pattern matching and move semantics is quite difficult to get right. Because you write a simple pattern, it works. You write a more complex one, and it's like, oh, but only if one of these 5 branches is hit, then it will explode. So I think generally, like editor and these sort of more complex things are a very good sort of test case, as long as you can sort of, I guess, bound the amount of time spent on them. Like as an example, what I do, I sort of dedicate Monday to Thursday working on my language, compiler stuff, whatever. And on Friday, that's sort of usually where I do other things related to it. So I'm currently writing a command line option parser, for example. And before that, I had the brilliant idea to write a markdown parser. But if you sort of slot it like that, you don't end up with like sort of waking up one moment and be like, oh, what year is it? And it's like, oh crap, I've spent the last 3 weeks on this.
I resemble that remark.
Yeah, so I'm not 100% sure what I'm going to do with like related to security and crypto. I don't know what the crypto laws are, but I know I can give code to anyone in Canada and the US, but I don't know what the rules are for software. So I think I'm just gonna not have any crypto at the beginning, and I plan to use Nginx as a proxy. So I just serve raw HTTP responses.
What was that, Nginx?
Yeah, Nginx. Nginx will handle the encryption and like SSL certificates and like all that. And people can use Apache or whatever they want, but I only ever use Nginx because yeah, it's not hard to use.
It's a nice and completely trustworthy Russian file HTTP server.
It's open source.
So they start
it's semi-open source. I plan it.
Yeah, the Nginx started as a spam server, so
yeah,
its primary goal to get fast.
I use the one that comes with my Linux distribution. I'm assuming that they vet it. I know they haven't, but I'm just assuming it. I'm not sure what I'm gonna about the IDE being written in my own language. I know SDL has a lot of unions. That's how they handle the event messaging system or the event system. I don't have unions yet in my language, so I have to be pretty far along in my language before I could even do like rewrite this in Poland. But yeah, for now, C++ is fine. Like I'm extremely used to it, and I did forget about how annoying the standard the C++ standard library is, because I kept on getting a lot of warnings about mismatching signed and unsigned compares, and they just do a lot of things. They have a couple problems. I wrapped a lot of things around my own data structures, and that just made life much easier. And there's no Veradic template for sprintf. Like they have a printf library in C++ 23, but I didn't seem to see an sprintf, so I couldn't write it into a buffer. So that was really annoying to me.
I'm sorry, C++ lost sprintf?
For Veradic templates, you can't do it.
Oh.
You can do the raw C one, but I wanted to do Veradic templates.
I don't know if we're ready for another topic, but I have one that's short, but not very exciting.
Yeah, I'm done.
Yeah, I mean, good.
So the last few days, I've had to do a project that I really didn't want to do, which is generate and write out ELF files. I could not find anywhere that generates them properly. Like I found a C++ header only library that does it, but only some section types. And So I finally just spent a couple of days and went through the standard and wrote out like, and speaking of things you don't want to open source because you don't want to have to maintain in the future, this definitely goes in that category. I may open, my strategy for open sourcing that stuff is I open source it with zero explanation or documentation on MIT. If someone wants to use it, they can. They won't. They can.
I'm just really curious if the specification for that actually matches what works.
Well, so I just actually, while we were talking, I finally got a file that I generated to be read correctly by both readelf and LLVM readelf. So more or less, it seems to work.
Wow, because like with GCC, all the specs around the GCC binary formats, the specs are all wrong. Like, so you actually have to look at the code and tools and reverse engineer it to get stuff to work.
Yeah, well, that's why I'm hoping that LLVM readelf is reading the same way that LLVM is, but I don't know if that's actually true. Yeah, I'm hoping actually someone's going to say, oh, you're wasting your time because you can do it easily using this. And then I can throw away this stuff and do that. But anyway, it's I think I got through the most annoying part because now, you know, my string and symbol tables are actually being interpreted properly. And there are a lot of flags and stuff that aren't very well explained, and I have really no clue. But I'm just, my plan is just to like compile, like make some .o files that are like samples of things with things in them that I need, and then see how readelf renders them and kind of do the same. Fortunately, people are consistent with their terminology and stuff. Like even when readelf gives a message, it says like st, you know, bind is invalid or something, and you look in the documentation, there's actually an st bind section. So
that's helpful.
Yeah. Anyway,
are you writing elf files for your PE array, or?
Well, so the problem is that we've got 2 generations of hardware, and our first generation is kind of, you know, it's not end of life, but it's getting close, and I don't really want to build a huge library of software for it. And a lot of stuff has been done. So I decided to write out so that the linker, the LLVM linker, can ingest the programs I compile and link them into libraries that are compiled using the old compiler. And so, and then for going forward, I don't need any of this stuff. So it's kind of like a stopgap solution, which is also why I don't really want to do it. I just need it for, you know, the first generation stuff.
Right. Okay.
But yeah, but I do need it. And so, yeah, it's been like, I don't know, about 3 days of work so far, and it looks like it might be another couple days, but it's not the funnest part of doing this project.
Yeah, the last time I touched a linker was back in the 80s. I mean,
not even the 90s.
Wrote innards of one.
Yeah, I've never really dealt with or looked at linkers, and so it's all learning experience. But I've got this great book that someone gave me.
There you go.
All of the information in there seems to be incorrect and outdated, though. So not sure how useful it is. Conceptually, it gives me a bit.
There's a lot of history in those.
Yeah.
The linker's been around a while. All right, what else? We got 30 minutes, maybe, plus or minus.
I just wanted to say, like, sorry, yeah.
I just want to quickly add that I once used readelf to look at the dwarf information that TCC made, and yeah, it was not usable. I mean, I'm assuming that TCC just did the minimum it could do to get something working, but yeah.
The dwarf is horrifying. I'm not definitely not doing anything related to that.
Okay, good. Yeah. So yeah, I just wanted to add that.
All right, Adrian, you had something?
Yeah, no, I do sympathize with Darrick there. Like, so since my language is kind of aimed at well, like bare metal software, I'm just like being pretty pretty ridiculous. I just emit like binary. I just emit binary to a fixed location. Nothing is position independent. The linking is super trivial. There is no like ELF or nothing I need to support, because like when I'm writing an OS or something, like I always have to, like, when I set up a new project, I first need to compile something to an ELF, then I need to remove all the sections, then I need to like make sure that all the like pieces of code are at the right location. So this is like one of the accidental complexities that I don't enjoy. I mean, writing application software is the happy path of most languages. So yeah, and that's not the case for me. So I can make it easier, and then the linker actually becomes super trivial. But yeah, I just wanted to say that. But actually, my main thing was what Cameron said. It was a bit long ago, but like, him mentioning the like him baiting Levo into doing something in 3 days. I love that, because I think so many things I've done because I got nerve sniped by people who just challenge me, or just like, either directly or indirectly, and I love it.
No, that's not what I'm doing. I just don't think he can do it. That's all there is.
that doesn't matter what you like. If you say that, that's already an indirect challenge. Like it's awesome. I mean, there are some people in the like in certain Discords, and they
right,
kept
Adrian.
me,
I think that one went right over your head there.
Yeah, I know. I saw his eye roll. Yeah, I guess I'm a bit I'm a bit slow with puns and like, sarcasm.
Oh, excellent.
Yeah, I am German. I don't understand like humor. No, like I don't know. I got like I once talked about with a guy on Discord about like lexers and stuff. It's just like, very trivial things. But then he mentioned how I wouldn't be able to write something as fast as this little like regex based tool, and I told him, well, that's actually not true. But then 3, 4, 5 people kept piling on me and telling me, hey, you know, this is like whatever you're gonna do, it's gonna fail. You're gonna be like, perform miserably. Whatever you're gonna write is not gonna be fast. So I immediately dug into, okay, how does ARM like Neon SIMD work, and sketched out lots of different designs and something, and I profiled for weeks and finally got a result that is like 40% faster or something, and it's super pointless. It's not portable. It's super unsafe. It's sometimes segfaults. It's like a complete utter garbage and waste of time, and I love it. You know, this is
gotcha.
So yeah.
So my PhD was basically, you know, done that way. Some guy said, you can't do this. It's like, well, hell yes, I can. Here you go.
So on the topic of Dwarf, which is the debugging standard, right? Does anyone know any good resources for actually generating Dwarf directives in assembly code? Or is it just one of these things where if you know, you know, and if you don't, you're screwed forever?
Well, I assume you can spend half your life and learn it, but it's not forever.
Yeah, I think you have to learn how Clang does it, and then you just copy what Clang does.
You output C code and you type Clang.
There's a lot of, it's very well specified. It's just a lot of reading. Is there something specific you want to do?
Is it actually well specified? That's the question.
So look at the chat, because our resident librarian has posted whatever link you need.
You can throw them in the doc there too, please, Matt. But I'm looking at you. So how many megabytes is this documentation?
It's quite a read. You don't read it all that much.
Jamie, there are also tools that verify that the Dwarf information in assembly is correct. I remember the authors who presented this were talking about Linux kernel as the motivation, because Linux kernel often uses straight inline assembly or in just assembly files, but they also want to have debugging information in those assembly files. So you have to write Dwarf directives by hand. And this turns out to be surprisingly error prone. So they have actually created a tool to verify the correctness of this Dwarf information. That's something new. So that may be interesting to look into.
I would have said it was not surprisingly error prone, but you know.
The reason is because
might have been a little bit of sarcasm on my side.
we run a compilers project at Imperial, and the end of the project they're allowed to go on and do any extensions that they want on their compiler. And my suggested extensions list was going to include debugging information, but I felt like if I was going to do that, I didn't know how difficult it was. So I should eat my own dog food first and implement it on the reference compiler, which introduced me to Dwarf, which made me swiftly stop. But I was wondering if there is, and this link might just do it for me, I guess.
Yeah, it's very, very complicated. The only way I had it successfully working, I didn't write it myself. I just used, I generated the types through LLVM-IR, and then the LLVM did it for me. So generating the types from my compiler, that's doable. And I still got it wrong in a few places, but it was manageable. Doing it raw by hand, like you really need a type system and a whole lot of things to do it correctly. It's very difficult.
So this would be generated by the compiler. So in that sense, at least it will be not completely handwritten. But
like if they were doing it, if they were generating LLVM-IR and you want to say at the end of that also include the bug information, that's a little bit more reasonable. But like writing it in, like generating the actual binary, that's significantly harder.
Yeah, so it'd be generated into plain x86/ARM assembly.
Debug info?
Yeah.
Mac does something different. So if you say ARM, you mean Linux ARM. But like,
yes.
I did the debug info for the JVM, but I don't think that counts here because I was both the producer and consumer.
Yeah.
Makes life a lot easier.
It does. Okay, cool. Well, I'll read those. I'll read the links there and see if anything insightful pops out.
Yeah. I did want to ask Cliff something based on the Discord. So I forget his name, but he was asking about how to handle segfaults and exceptions.
Debian.
Did
I can't pronounce it either.
Did you mean that when you in your segfault handler you actually modified the stack and then returned even though you modified the stack underneath yourself?
Yes, but
okay,
very carefully. Okay,
I just wanted to make sure that's actually what you did, and you didn't do like a long jump or anything like that. You just
no. This is we have too much going on. So you catch the segv and the segv handler. The handler is an ASM stub that just dumps all registers in some sensible place and captures the PC and the SP and calls into C code. The C code decides what he's going to do to the stack, which if you're like popping frames until you get caught by an exception handler, you might have to unwind a bunch of frames. Some of them are compiled or JITted or whatever, and some of the interpreter frames. And then you want to repack some JITted frame that you're going to jump in the middle of because that's where the handler is. So that's all laid out in the debug info. So you end up with a pop X amount of size from stack and then repack a frame that looks like Y. That information is tucked away in a malloc heap bit. And then you return back to your original handler. In assembly, he says, pop the stack by X, push it by Y, copy the bits from A to B to build a JITted inline frame that you're going to jump to in the middle of that's nested layers A, B, C, and C's got the handler that's the segv because C called off to whatever, and you had to unwind back to whatever. So however the stack's repacked there, the ASM piece the C piece does the smarts, builds you what you want the stack to look like. The ASM piece does the work, and then the last thing the ASM piece does is say, I'm all done. Go back to running the code at this address instead of at whatever the return would have been.
Okay, that's what I thought you were saying in Discord, but yeah.
So yes, the stack
go to
is repacked. And we're not using long jump because we're not jumping back to C code, we're jumping back to JITted code.
Right, but it's basically an implementation of long jump.
Yeah. It's just not the C's long jump, right? And we had to repack the stack along the way. So that was, deopt in a nutshell there, of course. It's like, it's not rocket science, but there's a billion tiny fiddly bits.
Yeah, there's only two things that can go wrong. You've got off by one errors.
Yes, exactly. And how many off by one errors do you have? Oh, geez. That was the start of debug a lot, blah blah a lot flags were all these paths that you only took rarely, but they had to have some very complicated thing happen. Because they only went rarely, bugs would lurk in there forever and a day. So deopt a lot was one of them, GC a lot, safe point a lot. There's a lot of them. And they would try to make the rare case common so you could debug it. All right, what else? Well, we're gonna wind it down in a minute then.
Can we talk about save nodes?
Yeah. You're new
Sweet.
here. I've talked about it recently several times. So ask first, and then there's a presentations that you can find, or I can find for you. Ask.
Okay, so I'm wondering about some architectural differences between sea of nodes and a program dependence graph. In your Joker talk, you mentioned that you would have wanted to do a program dependence graph, but it was too new at the time that you were starting C2. I'm not really familiar with the program dependence graph. From what I've seen, it looks similar. So I'm just wondering what the difference there is.
In the sea of nodes, I actually have a real control flow graph embedded in the same graph structure. So you have a control flow graph that's a classic control flow graph. You have to walk it oddly because the nodes and the layouts are a little different, but it's a classic control flow graph. Program dependence graph removes even that, and you can have free floating independent chunks of code that do not serialize so nicely back to some form that you could actually do eventually a layout, and you put bits in memory and you can execute. So as an example, if you have a loop, and in the middle loop, you have a loop invariant test, then in a program dependence graph, the loop invariant test only depends on the test, which does not depend on the loop because it's loop invariant. So it is not structured as it's being inside the loop. Now, the outputs of that control are only used in the loop to gate some behavior that happens on every execution, always left or always right, because it's a loop invariant test. In the sea of nodes, the control flow graph would include the if control dependent inside the loop. So the test has a consumption in the loop, forced in the loop, that says I'm always left or always right. The test itself can be computed out as a Boolean outside the loop. In a PDG, it's not even in the loop. The control test branch is not in the loop. So in the specific case I just mentioned, the serializing is fairly straightforward. In the general case, the serializing is much more difficult. And I was already solving a lot of problems, so that's why I didn't want to solve that one too. So
interesting. Yeah, it sounds like you'd probably end up with problems in serializing code too late, because you'd serialize it right when it's first used by all of its dependents. And maybe that's too late. Maybe you'd want duplication, so you'd need a metric there.
Well, the optimization is I'm going to clone the loop and do loop splitting, right? There's split two copies, one with the test true and one with false. But in the PDG, you can get a more generalized version of this kind of floating control, where it's not obvious how you do it. Like you have to move a diamond, which is free from the loop, back into the loop, and that's, you know, like I said, in the more general case. So you can go read the papers, they're very old, and see what they had about how to go solve the sorting it out.
So I'm coupling sea of nodes with acyclic egraphs. It's a pretty new technique, and the technique only came out just this year at PLDI. But
yeah, you got a link? Because I haven't heard this one.
Sure. I'll send it after I talk.
Yeah,
so,
yeah. Throw it in the Google Docs.
So the idea is with an egraph, it throws all of your nodes, all of the peer nodes into a a hash cons over equivalence classes. And so you'd have something like for arbitrary precision arithmetic, you'd have x times 2 and x left shift 1 in the same class. So suppose you have the expression x times 2 over 2. You want that to become x if it's arbitrary precision.
So C of nodes for ints and floats and other sort of anything that's primitive in C of nodes will totally convert those to an equivalent form without a separate equivalence class. So maybe we need a more complicated example. Like there's a trivial people that says, hey, times 2 left shift by 1. Okay, now these two value numbers.
I'll paste a picture into. Oh, I need to be signed into Google. I don't do that.
You want to share a screen? You can put it or put it in Google Docs. Let me go find Google Docs.
Is this the picture?
Yes, that is what I'm trying to share. All right, so you start out with a times 2 over 2.
Oh, you lost sound. Wait, Thalia.
Add node to the same class as your times. And then you do a reciprocal.
Can you hear me? How about now? Can you hear me now?
Yeah, I can hear you.
Okay, you lost like 20 seconds of sound, so you have to roll back and just say it again. Oh gosh, you got silent again. Audio problems.
Oh, it's when I switch tabs. That's what it is.
This smells a lot like constant propagation.
Yeah, I'm looking like constant propagation here. I don't know what the e-graphs. I don't know what this is doing that's not constant propagation yet.
So in this case, nothing. But combining that with so Chris Fallin of CraneLift has generalized this to work with control flow and created acyclic e-graphs.
Okay.
And so
C of nodes does control flow peepholes just as well. Maybe we should go down this the what the hell you do with C of nodes.
Yeah, there is a ton of overlap. I think he's reusing a lot of machinery, but calling it something else.
Cliff, have you looked at e-graphs before?
No, I just had. I'm hearing keywords that sound very familiar. So I have not. So there's something different. I'm sure. I just don't know what it is yet.
Yeah, it's very similar to C of nodes, but a big difference is that C of nodes mutates a graph, and e-graphs accumulate all of the possible transformations and then try and pick later what's best. And so they have this like additional graph structure for saying that so that you can.
So C of nodes is just trying to monotonically roll down the hill to find a low point. Whereas this seems like it's trying to get more of a sense of the landscape, that there may be a low point that's not what you get if you just roll down.
Almost done. Just the idea seems to be that it's built on the assumption that you cannot do these graph transformations monotonically.
Okay, and I am built on the assumption. I'm trying this. I'm built on the assumption I can do them monotonically. That I will hit a Church-Rosser single step property and achieve a globally correct minima, maximum, whatever, irregardless of the order. And I am currently asserting for that on large things. So I don't know, like I need to see a transformation that I can't guarantee I can get at from any direction. So far, I haven't found one, but
I think one of the transformations that I recall them showing was that you could like multiply by a power of 2 and then divide by a power of 2. And so the multiply by power of 2 can be turned into a shift, but the divide, it's not as safe to do that. I think it's their idea. So then, you know, basically you don't want to get stuck where you've done the
right. If you have something you can't unwind in any direction, but I claim that multiply and divide can be unwound if you've multiplied first, because that's part of the obvious pattern. That the divide by 2 has a particular pattern that you have to screw around with to handle the negative case or whatever. But if you've multiplied by 2 and then you feed it into divide by 2, you can take the next step and get rid of the extra case. So I claim that those two would be able to be done in any order, but you have to have more than just the divide by 2 pattern. It has to have a special hook that says.
What would be interesting is bigger rewrite. So let's think about inlining and loop unrolling, for example.
Right. For example,
you may be only able to inline when the function is below a given threshold, and just because you have unrolled a loop in that function, you might have blown up that threshold. But maybe inlining this was actually a better idea. So I'm thinking of optimizations, bigger optimizations like that. Select from among inlining the function or inlining or unrolling loops inside that function.
So my theory on that particular one is I would have to take that into account. No, these are both code increasing transforms, and I'm not going to pick one or the other. I'm going to pick neither or both. And that's part of the game being played to make it monotonic. So there's another game here that says it can be not monotonic and it could be monotonic if you made certain choices, and are those choices good ones? Whereas if you listed all your choices and there was a certain set of patterns that were good and others that were less good, but you accepted the non-monotonicity, you might find the exploration of the one space of I can't claim one dominates the other, but I am going to attempt to be one that's monotonic.
So the biggest benefit that I took away from egraphs is, well, particularly the acyclic formulation, is that it doesn't have to be monotonic. It's just linear. And then they are able to express rewrites with a DSL and generate Rust code for the compiler. So it's not like, so I'm most familiar with Graal. They have all their rewrites handwritten in Java. It's not like that. And so it's trivial to add a new one. And not adding a new one isn't a huge cost. You don't have to schedule it. You don't need a 500-line pass scheduling definition function like GCC has. And this is a text file with no code. It's just ordering passes, and that's crazy. Egraphs need none of that.
GCC passes is a different issue. That's the whole point of the big people pass in C of nodes, is it covers all of those all at once. One thing that having a description, I know, Darrick, you have a much tighter description language because you're using closure for your description of what a people pattern rewrite rule is.
So yeah, because my difference from Cliff, I think one of my biggest differences is Cliff cares about writing compilers that execute quickly, that the compiler executes quickly. And I only care about that just a tiny bit. And so what I did is I wrote all of my graph rules as separate individual rules that are matched against the whole system. And so my rules are also like, I just define them in any order. I have them kind of roughly categorized. And then I have a few files that contain them. And I have, I finish with all the rules in one sort of group, and then I move on to all the rules in the next group, and so that's the only ordering that I have. So I also don't have any particular scheduler. In fact, my work list is a set. It's an unordered set.
Yeah.
So,
but if you run the rules in random order, do you converge to the same thing?
Typically, although I think it's occasionally I may get something wrong, but it's probably just bugs in my rules still.
You haven't been testing that.
I haven't been, well, in fact, I kind of do, because I have a lot of tests that test intermediate states. I think I showed you guys that form that I created that sort of gets rid of all the numbering, but lets me sort of show kind of key information about the nodes so that I can just have a text blob in my test and then test the output, and then I don't control that. And as things change, pass ordering, rule ordering ends up being quite different. And those tests very rarely fail. So.
Okay. All right, well, I'll take a look at the eGraphs link. That sounds good. But I'm like I said, I think I'm coming at something that's going to give a similar answer in the end.
Yeah, I think
interesting to think if the eGraphs, in the case of what Matt was saying, where like bigger decisions like loop unrolling and combining could be like incorporated into a compiler that is otherwise doing just normal sea of nodes, and you could have like sort of like a hybrid. I don't know if it'd be possible though, because as soon as you do an inline, then you start folding all sorts of things inside the function that you've inlined into, right? So
the point is that you're going to inline eventually no matter what. If you're going to inline on some path through, you have to always inline. And then the inline itself just becomes a bit more graph. And since everything else is I won't say monotonic or has the Church-Rosser one-step property, you'll eventually converge again. So I think inlining by itself is not a problem. It just enables a larger graph and more shit to happen. But you do have to decide I am or am not going to inline at some point, sort of no matter what happens. So if your inlining is triggered when you know a certain fact, you discovered the receiver for a virtual call, and now it's a static known, then the rule has to be, you're eventually going to discover that receiver no matter what. Having discovered the receiver, it's now worthy of inlining, so you will always inline, and then you'll end up in the same spot again.
And do you have an ordering in terms of thinking about loop optimizations or unrolling, unrolling, or versus inlining? Like, would the loop operations always happen before or always happen after the inline?
Right now, in AA, I'm not doing any loop ops, and in C2, I didn't try to do this thing. So C2 did inlining way early, then it did loop unrolling, and then you were off to cogen and out the door.
Right. So in C2, inlining is definitively first.
Yeah. And there were profiling heuristics, and loops typically triggered the profiles. So typically, if there was an interesting inline in a loop, it always happened because the profile told you to. But there was not a compiler ordering where I first said, do something, discover some fact, then inline, then discover more facts and whatever following, and then loop or back or whatever it's going to be. That's not what's happening. It's always inline first.
Yeah, because you in C2, because of how things work, like your loop counts like practically as you're parsing, right?
I'm parsing, but yeah, as I'm parsing bytecodes, typically I do know the loop counts while I'm parsing bytecodes. Yeah, not hard. I know the profiled approximate numbers, but I got a good number out of it.
Yeah,
there were a few cases if you had racing threads that were bumping the perf counters directly using uncased non-atomic counters. The counters would all saturate. I would recognize the saturation position and know that these are all very hot, but I couldn't tell one hotness from another. And then I switched back to classic style heuristics for what loop was inner and what loop was outer and where the control flow went. But that was
hard to tell which infinity is bigger.
Exactly. I had a pile of infinities, and I went to classic heuristics for which infinity was bigger. Yes. Yep.
Yeah. I've actually been thinking about, so I have a sort of funny problem where in my kernel code, typically there's like an infinite loop at the top. And so I was not sure, I've been sort of unsure how to deal with that. I finally decided I think I should just make the iteration count on that loop 1. I don't want to really unfold or do anything with it. And then I just want all the counts inside it like not to be affected by it. So
if I had an infinite loop the programmer wrote directly, the main issue I ran is I had to have an exit so the loop wasn't unattached from below. So I put a never branch exit. Then I let the count, I have an approximate, so these are all integer counts. I had an approximate value I used as the max int for infinite. But otherwise, these loops were typically uninteresting to unroll because they were big.
Yeah, exactly. So
as soon as you have like a subroutine call, function call in a big loop, your time's in the function call, not in the loop.
Yeah,
So
yeah.
don't bother.
I think it's reasonable to be able to explain to developers as well that like if you write a top level loop and you actually want some amount of inline like unrolling of that loop, just write like out like a top level infinite loop. Just write like a loop inside of it that's of count however much you want it to unroll.
Right.
And that'll give you the unroll.
Yep. All right, Thalia, I cut you off hard and I apologize. Did you want to say more about egraphs?
Not a lot more on egress, but I am curious why you chose sea of nodes instead of the more traditional basic blocks, because and trade-offs between the two, because I've been wondering if sea of nodes corresponds heavily with a JIT approach, and so it's always fast compilation and maybe worse.
Didn't the basic blocks kind of come later, or do I have that backwards?
I thought basic blocks were first.
I mean, at this point, sea of nodes corresponds with JITs a lot, but that's just because C2 did it. And
right.
It's
so here
the
is
famous JIT.
the paper. Here's a paper where I went from a classic IR to sea of nodes. Let me go put this in here. Oh, fuck you, Dropbox. I have a Dropbox fail here. Let me get my links sorted out. Windows and Dropbox. There we go. Finally.
There's no like negative trade-off on generated code speed with sea of nodes. It's only just associated with JITs because only JITs have used it.
Compared to what I had available to me at the time as what people did with IRs, the sea of nodes both let me do more optimization, let me do more sort of perfect optimization because I could hit this fixed point I've been talking about in one pass instead of 500 passes out of GCC. I just get in one pass. That led to a lot of performance. It also led to a much simpler internal design. When I went to Sun, there was an obvious way to implement the sea of nodes implementation, building, optimization that was much faster than what other people had been doing. So grad school, I'm just trying to understand the complexities of a compiler. I come around to sea of nodes because it makes for a simpler overall compiler design. I don't have a constant propagation phase, then a dead code elimination phase, then an XYZ elimination phase, then back around to constant propagation again, then an inline phase, and another constant, whatever. None of those phases disappeared. So that made life a lot simpler. When I got to Sun, there was an obvious way to make it run fast too. So it's both simpler and faster. So I needed speed because I'm doing a jet, and I wanted simpler because simpler makes life easier. So that's the reason, the reasoning, that the way I got there. Did you not see the two slideshows that I've done on Coffee Club several times that talk about where did they go here? Easy SSA and sea of nodes. Both of these talk about, well, the first slide up here, let me go see if I can just, has the obvious thing. Yeah, so here's the obvious slide. I'm going to screen share. We'll just do this one slide here. So I am talking about showing an expression written in like ASCII on the left, distance at the bottom left, distance equals x squared plus y squared. Somewhere I have a set of tuples on a classic compiler IR. So that would be some destination register, register X, some opcode that made it, some other arguments I'm not showing because X and Y predate the distance computation. Then about the third line of that middle table, I say X times X goes to R0, some temp, Y times Y to another temp, add the two, store it into something else. Okay, so now I have a standard 4-entry quads that when I grew up in compiler land, those were called quads. So then I'm going to do an alpha renaming from table 1 to table 2. All I'm going to do is rename Rx and Ry and Rd, R1, R2 to be the pointer address of the quad. It's a strict alpha renaming, but the name's funny. It's a pointer, not a textual name. Having done a rename this way as pointers, now I basically have nodes. So the next step over on the right is just a shape change of the second table. There's no semantic, no pointer change. It's just a shape. I just drew it differently. Now I have a graph. So I went from quads to graphs in just those steps.
Yeah, I've got
my thinking that got me into the sea of nodes, and why I did it was now I have a graph to work with. Like I do people rules and shit. So all kinds of stuff falls out of this.
What determines the size of the compilation unit?
In C2?
Yeah.
Yeah. Somebody triggers a threshold that says time to compile. So you hit the 10,000 count. You crawl a stack looking for counts that are transition from high to low count. So there's a heuristic that crawls the stack, looking for the root of a compilation unit. Also, the heuristic takes into account if I have a compilation unit existing already that's large, because you don't have lots of differently inline overlaid compilation units, or you blow out your iCache with variations. So there's a tiling of the execution space. It's going to happen via heuristics only. You pick a spot. Here I found a loop, and the next guy up, the count goes low, one down count was high, there's a loop involved. I'll stop at the loop that contains the loop. So you stop the guy.
And that never explodes to sucking in the entire program.
Yeah, right. And now, having started at a root point, I begin inlining, and I guaranteed inline the trigger point. So whatever chain of events I went up the stack to get to, I'll walk it back down and say, inline all these. But then there'll be other things nearby that say, I'm useful to inline. And useful meant too small to care, getters and setters, or high enough frequency count. And there's some thresholds that did more or less, and some things for recursion to handle and whatever. There's a bunch of heuristics. You inline along those fronts. So you get a tree of inline methods and things they call down some layers, mostly based on profiles. And then you were done with inlining. That was the limit. So when I actually parse bytecodes, as soon as I hit a function call that I've decided I'm going to inline, I immediately switch over to parsing those bytecodes. And I build all one complete coherent graph. Whereas in AA, I do heuristics that say, hey, it's time to inline this guy in the middle of doing the peoples. And it's like a giant people rule that Matt was talking about. It makes a big change to the graph, but it's treated like another people rule. And it just takes a wad of graph over here and clones it for the inline, and then it jams it over here and stitches the edges together, and then the inline's done. All right, so Thalia, did this head down the path of where you want to go? I can pound through more slides. Everyone here has seen these slides before, so do that.
If you've done the slides in the previous meeting, I'll try and hunt for that. But if you've already got a link, that would be great. Because it's hard to find them because they're just the date on YouTube.
Oh, you can't search the description? I don't know. People have found them before. I don't remember when I last did it. We're also at 2 hour mark.
You should ask our librarian.
Yeah.
Okay, search by description works. I'll just do that. Great.
Okay.
Matt's gonna be out of a job soon.
Yeah, I was just thinking about the trade-offs of why GCC is the way it is versus why C2 is the way it is. That the really early C compilers very much made the assumption you can't fit the whole program code in memory at the same time. So I want to do some compiling and write out a .o and do some compiling and write out a .o, and then I'm going to come back and try and do the link that I can do without ever having as much in memory. Whereas C2 assumes that your whole graph will fit in memory.
Yes.
And you're able to run these things.
Yes.
And I think that's one of the reasons that it ended up in a place of lots of peephole rules operating over a graph, as opposed to lots of compiler passes operating over .o objects that could try and get things in from tape and do a processing pass, and then out to tape again, and then in from tape and do a
very early, and I worked on such systems where they do that. The compiler was too big to fit in memory, the compiler itself. And the IR had to fit, but they would, load different passes, run them, load the next pass, run it.
Right. C2 assumes that both C2 and the compilation unit fit in memory simultaneously.
Well, my passes were smaller because it's just mostly the graph rewrite rules. When I started loop ops, then by that time, other compilers already assumed that the whole program and the compiler both
I mean,
fit.
you'd put the passcode in one card feeder.
Yeah.
And you'd put the source code in the other card feeder, and then you'd get, yeah.
I did this thing, but by then I got it off of a overlay linker. But the overlay linker would load in the next pass over the
So
code.
by the way,
space.
Guy Steele still has exactly one punch card in his office that he uses as an example. He'll actually pull it out and he'll actually explain what each hole means and
Oh,
how
God.
it's
for about
That's why I get
60
annoyed when
years.
people set their editor to 120 columns wide. It won't fit on the punch cards.
it won't fit on the
anymore. What are you
fucking punch
doing?
card. Yeah, who needs more than 80 columns on a punch card anyhow?
It sounds fun once to write on punch cards, but not every day.
I used to carry a large punch card deck for about 20 years. It was my Star Trek game I wrote on an IBM AS400 in RPG2, Report Program Generator 2. Never mind.
So for Christmas, we need to get Cliff a slide rule.
I have a nice high quality slide rule for my dad. What are you talking about? It's upstairs. I can come down and bring it. It's ivory. It is like literally an ivory slide rule because that was the engineering high quality slide rule of that era. And I used to know
It's
how
nice
to
that
use
you
it.
have an ivory slide rule from your time in the ivory tower.
No, from when elephants, were used to make engineering tools.
Exactly.
All right.
So I was at a thing for the British Chartered Institute for IT with a bunch of programmers who were around during the days of punch cards, and they told a story that I think it was very early on. There was some punch cards needed to be transported from the UK to America, and the cards got stopped in customs. And the customs officers asked, "Are these cards valuable?" And the people taking them said, "No, but the holes are." And apparently got them detained for a few hours.
Yeah, that's correct.
How much does software weigh? Back when software weighed a negative amount.
Yes, correct.
Well, I think it's always fun to tease and make fun of the guys at Border Control. I mean, what can they do to mess your life up?
Oh, Jesus Christ.
Anyway, that was the funnest search I ever had. I can't walk now, but
They were checking all the holes. Let's just stop while I'm behind because I'm getting behind her.
That's one of the courses I'm tempted to put together is a history of computing taught from the perspective of Unicode. Because there's all kinds of lessons in there where you could be like, okay, so look at the control characters in the first 127 characters. All the control characters are at the beginning, except for delete, which is 127. Why is delete at the end? And the answer is, well, you can't unpunch holes. You can only punch more holes. So all ones needs to be the I deleted this character because that's the only thing you can do.
Yes.
That is still in Unicode if you are trying to figure out what's going on in UTF-8. 127 is delete for the punch cards because you can't unpunch a hole.
That's why. That's amazing.
You could totally teach an entire semester-long history of computing based on Unicode, and just as you get further through the numbers and
more
international politics and standards
there is, of course,
bodies.
bad news for Levo when he discovers that monospaced fonts with Unicode are not monospaced, but we'll save that one for another week. Certain Unicode characters actually far exceed the width of the monospace.
Vertical tab, anybody?
No, I'm talking actual rendered characters that are 1.5 times the width. Even in monospace, it makes absolutely no fucking sense. Yes.
Oh, Unicode, ASCII. Yes.
Not my problem for another. Not my problem.
Yeah, another time.
I'm never going to need those characters, I believe.
You're in the IDE business, Levo. You got to support this thing. It's not working with my Unicode.
That's when I open source it.
That does bring up an interesting question. Where'd you get a font from?
As soon as you get paid, then you're in the IDE business. Don't let them kid you.
What was that font question?
Where do you get them?
What font did you use? Where did you get a font? I assume that you don't get to pick your font on this editor.
I
It seems
wrote
like
my own
it's
back
got
when
one hard-coded font.
When I did this thing on my Radio Shack color computer, I wrote my own font. Thank you very much.
So I didn't just write my own fonts. I actually wrote my own font editor because there were no fonts. So I created a font editor. This was for game development.
Yeah, right. I just used zero hex, blah, blah, blah to go fill
it
out
turned
the
out I was a lot better at building tools for building fonts than I was at building games. So
all right. We are well past the standard here. Why don't we call it quits?
Share my screen again. Oh wait, yeah. Here's how to do it.
You want to go again?
No. I'm just going to show the font thing. Can you see my screen?
I can.
Okay, so essentially, I have a few hard-coded fonts. On
you got a TTF reader.
Yeah, but I essentially just do this. FC match mono, which gets me monospace fonts. Then this basically gets the file path. I'm just gonna run this in my terminal. Oh, yeah, FC.
Did you write a TrueType font reader?
No.
He used load font.
So that's STL. Or let me just go up here. So this thing here,
STL has a TrueType font reader. Today I learned.
No, STL.
Yeah, it's part of STL. It uses Open TTF. I forget what it's called, but
that's a lot of dependencies. That is a lot of dependencies. I'd be worried if I were you, because I mean, a font
You're
reader
not.
can only,
remember, you're not in the IDE business unless you get paid.
A font reader is like 3 days of work tops.
And so, anyway,
Cameron, how confident are you you're not evil?
All right.
I'm still
Google says Google's not evil.
Yeah. So
oh, that's right. He works for a different company that has less of a problem with
Oracle.
Yeah.
Done. Stop. We're killing each other here.
I wanted to say something. I never got a chance. Okay,
go for it. Do it.
So I wanted to go back to like the egraphs idea. So there's a more general question. So there are two styles of programming I've seen proposed. So one is sort of this top-down approach where you say, I want a program that does X, and then you go and you divide that into components. You're like, this does Y and Z and A and B. And then you write, you implement a procedure for each of those methods, right? And so then you write all those methods and then you put them together.
We got it.
Yeah, and the other is sort of this bottom-up style where you write little functions that do, kind of things that you think might be useful, and then you write more and more of those functions. And then at the end, you sort of just put them all together into a big, rewrite engine, and you say it'll rewrite the rules, and then, there's compiler magic, so the rewrites happen, and then, it all works.
All right, wrap it up, Alan. We got it.
And so the question is, which style is more practical? That's what I wanted to ask.
That's the wrong question.
You must use both.
The right question is when you have brilliant people that work with type A and you have brilliant people that work with type B, how do you put them together in a way that instead of killing each other, they produce something brilliant? That's the right question.
There are times for the top down, there are times for bottom up.
That's what I said.
Yep. And no, you said, and now get two people to work together without killing each other.
No, not two.
That's a problem.
7 is a good number. 7.
Oh, 7. Okay, fine.
All right.
Who was the guy at Bell Labs that got all the people to work together on C and Unix? And
C was 2 people. 3 people.
Of course, what you have to do is to have all of them write 7 different inlining passes and then just let the end user select which inliner they want to use for compilation. It's easy, Cameron. I don't see the problem.
I think as soon as we settle tabs versus spaces, we'll jump on this one.
Well, I settled that. It's 3 spaces. We settled.
No, you settled. I didn't settle on 3. Are you kidding?
4 tabs.
Besides, you're not using Emacs, so you're wrong.
just getting a group of smart people to work together at all is enough to get you know, a major motion picture made about you. I mean, look
All
it
right,
up. And
getting smart people to be quiet so we can end this conversation is also hard.
Silicon Valley, the movie. I'm waiting for that. They have 6 seasons. Now they
there's a
just need
TV show.
All
Since we're
right.
going off the rails, there's something I want to say about punch cards and
daring you to hang
IBM
up, Cliff.
360s.
I'm going to moderate and claim bringing that question for next week. All right, it was very fun, and hope to see y'all again soon. Bye-bye.
Bye.
Bye-bye.
Bye.